All right. You have learned that the area is the number of square units needed to cover a surface. Counting square units on a circular surface can be challenging. Here is a counting method that gives a fairly good estimate of the area of a circle. So today we're going to talk about area of a circle. Okay? What does area mean? Taylor?
The space, or like basically the area inside the object.
Okay, so it's the space inside of an object, right? Versus perimeter is what? What, Tyre? It's around the object, so it's the distance around, okay? So circular objects and square grids, do they work well together?
No.
Not really. So here is one way to estimate area. So here's what they do is they count the squares that cover any part of the circular region. Okay, so here are the squares that are on the edge and inside of the circles. Everybody see that? How many did they find? 60. Then they said count the squares that are entirely within the circle. So no parts go on the outside of the circle. How many did they find? 32. Now here is how they estimated the area. Is they added the two areas and they did what? Divided by
the number of...
By 2 because there's 2 circles, right? So what did they estimate it to be? 46. Is everybody good?
Yes.
Okay, so let's look at number 1 together. So if we box in the partial ones, okay, so I have how many? All right, so that's 32 squares. Okay. Now, let's do the ones that are entirely within. Are these top ones entirely within the circle? No. So it's pretty much going to be this little box right here for this particular circle, which is a 4x4 grid, which is how many? 16. So we are going to add these and do what? Divide by 2. So that's 48 divided by 2, which is 24. Okay? Are we good?
Yes.
So now let's do an oval. We're not really going to discuss ovals very much, but let's just see how it affects an oval. Okay, so it is wider. So 1, 2, 3, 4, 5, 6, 7, 8. Twice is 16 plus 40. So 40 plus 16 is 56. Because here's 8. Here's 8. That's 16. And this is 4 by 10, which is 40. All of them. So now we're going to count the ones that are full squares inside of the oval. We could probably count these top 2. Can y'all see my blue? Okay, so how many tiles do we have now? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Questions on where we got that from? So we're going to add them together and divide by 2. So it's 88 divided by 2, which is 44.
So does it matter? I'm sure it doesn't because you're only doing addition. Does it matter if it's like 32 plus 56?
No.
It doesn't matter which one.
Does it give you the same answer?
Yes, but I was saying, like, does it matter if
No.
you count the squares that are in the oval
No.
or outside? Okay.
No. Yes, ma'am.
I don't understand why you're counting the squares outside the...
Yeah.
Okay, so here's why we're counting the squares outside. Because this square right here has partial of an oval and partial not. Right? But I don't know if it's half the square is the oval or a third of the square or a fifth of the square. Right? Or like these little bitty ones right here where this just like this little corner. Okay, that's like a tenth of the square. I don't know what that is. Okay? So we are going to count the squares that have any part of the oval overlapping into it, or the circle. Does that make sense?
Yeah.
And then we're going to go back and count the full ones, and we're going to take the average of them. We're going to add them and divide by 2. Okay? Because we have 2 different measurements. So average of them is 2. And that's going to be our estimate.
Okay.
Does everybody understand this part? How we could estimate the area of a circle?
Yes, ma'am.
Yes? Okay.